Hi, my name is Bartek Skorupa and this is my first tutorial for AE Tuts Plus. What you are seeing right now is a scenario that we will be working on. We have the footage that was recorded on Digibeta 16:9 and it was the part of some TV show. PAL 720x576, 25 frames per second, and you have a very difficult task. You have to deliver it to the station that broadcasts 4:3. The material is 16:9, and you have to add the crawling text at the bottom that says this was shot yesterday. The material that I'm going to show you is actually not something that was recorded on Digibeta, but it was taken from stock footage for free. But I have prepared it so that it matches the scenario. So, how many of you would simply do something like that? Import the material, make a new composition of it. You see that this is, let's just render it out so that we see what it looks like. Something is not right because it was supposed to be 16:9 and you see that it is 4:3 and the proportions are not right. You're not that stupid. You know that you have to interpret the footage so that it uses the widescreen pixel aspect ratio, right? Okay. And you have to fit this into the composition. Command Alt Shift H. And this is done. And now we have to add a crawling text. Command Alt Shift T. And let's write down this was shot yesterday. Let's position it correctly. This is for television, so you know that you have to activate the title action save. At the beginning of the shot it should be somewhere here. Let's add a keyframe to the position. Let's go to the end of the composition. And let's simply move it to the other side. And you are done, right? So now, what you have to do, simply add it to the render queue. And this is rendered. Let's call it ready for 4:3 television. Save. And render. Okay, the job is done. It took us like 2 minutes or so, right? And you just render it out, deliver it to the TV station, and say, hey, give me my money. And you know what? You won't get your money. Instead, you will get a phone call from the client, and he will say that your material was rejected. And he will, of course, read you the report. The report will say the reason 1, exceeded color values, the reason 2, flickering, missing fields. So you would hang up and say something like, but having expressed your feelings, you would most probably want to fix the problem. So first I will show you how to fix it quickly, because you are in a hurry, and then I will explain the concept behind it. Let's address the first problem. The color values. Well, when you deliver something to television, the colors shouldn't exceed certain values, and the best way to fix this problem is simply to add an adjustment layer, call this broadcast save, and add the levels to it, and set the output white to some value like 240, and this should fix the problem. And the second one, missing fields or something. Missing fields? What is missing? Have I not rendered all the picture or something? Well, you have to know that the technical guys from the television have like thousands of clips to test, so they will never give you the full explanation of what they really mean. They will simply write down 2 words and you have to figure out what it's all about. What the guy meant was that the crawling text that you delivered gave him the flickering effect. Well, what flickering effect? I have watched it and everything was fine. Well, on your computer screen, yes, everything was fine. Because the computer screen scans the picture progressively. It shows you all the picture, then refreshes and shows you the other picture, and so on and so on. And the television, by its nature, is interlaced. So first let's make the technical guy happy, and then I will explain what it's all about. He wanted to have interlaced material, let's give it to him. Let's add our composition to the render queue and set the render settings to render fields, and let's set to render upper field first because we are delivering it to the PAL television. PAL television uses upper field first. And let's call this ready for 4:3 television interlaced, save, and let's render this. Okay, so what is interlaced? Interlacing is a technique that was developed early in 1930s, and it was developed to save the bandwidth. Remember that we are talking about good old analog television. The picture is separated into fields. Upper field of the picture are only the odd lines of this picture, and the lower field are even lines of the same picture. And the idea is to show the upper field first and then the lower one. And it happens so fast that we perceive it as a one whole picture. And this technique was developed in the beginning of 20th century, but we have to live with this until now. So, if the frame rate of our video is, for example, 25 frames per second, it means that we are shown 50 different images. We are shown 50 different fields per second. And this is how the signal comes to our homes, no matter if you have the CRT monitor, CRT TV set, or LCD or anything else. You are delivered interlaced signal. And only CRT monitors are capable of displaying it properly. LCD TV sets de-interlace what they get and give you 50 full frames. But those frames are of the half of the resolution. Missing lines of the fields that is currently displayed is simply interpolated from the existing lines. And this is done in the TV set itself. So if we are delivering anything to the television, we have to take it into account. We have to deliver properly interlaced material so that it's properly displayed on CRT TV sets, because LCD TV sets will do what they have to do to display it properly. Let's try to simulate this behavior. Let us import some other footage and let's make a new composition out of it. And I will drag some presets to the composition. I have simply created the solid with a grid effect, and it's set up so that we can filter the fields. So let's extend the footage to 200% so that we see every frame twice, and let's see this filtered by those lines by setting the track matte to alpha matte, and let's render the portion of it. And this is what you get. And it doesn't look nice on a computer screen, but CRT monitor is in fact lamp. So when we have the lines, they are shining and they give a bit of a halo on the missing ones, so you don't notice that there's anything missing. One field, the other field, one field, the other field, one field, the other field, and so on. In this case, because the material is progressive, both fields represent the same picture. So the same picture in fact is shown twice, so you have the feeling that you have the frame rate of 25 frames per second. Let's simulate the behavior of the LCD TV set. So let us simply interpolate the missing lines, and we will do it by creating a new adjustment layer, and we will add a fast blur to it, set the dimensions to vertical only, blurriness to 1, and we will pump up the alpha. By crushing the input white alpha level to 0, and we get the behavior of LCD TV set. Okay, and I don't know if you see this, but let's look closely. This is the same frame shown twice. You see a little bit of a difference between the fields. So as you can see, even progressive LCD TV sets don't display exactly what you see in the project. What you see in the project is an input, is a source. Then it's interlaced by the television. Then the television delivers it to your home. This interlaced signal is de-interlaced in your LCD TV set. And it will look a little bit different than the source. And this is why this is so important to be able to see what you are working on an external monitor, on a broadcast monitor. And this is important because of the color reference and because of the interlacing and its behavior. In this example, you see how the progressive footage behaves in television. So you may say, fine, so I can deliver progressive. Yes, that's true, but some things, like for example crawling text, behaves not correctly when it's delivered progressive. And I am not able to show you this on a computer screen, so you just have to believe me. Okay, let's go back to our scenario for a moment. In our case, we have to deal with interlaced source. This was shot on PAL Digibeta. This kind of camera, as well as DV, HDV, IMX and many other, they just shoot interlaced, meaning that they shoot 50 different fields. They shoot 50 different images and write them down onto 25 frames, or almost 60 when we are talking about NTSC. But I live in Europe, so I am really used to PAL and 25 frames per second. So let's just see this footage once again. This is the one. But let's interpret this so that it doesn't separate fields. And now we see both fields at the same time. So when you watch it in a PAL television, you will get the feeling of 50 frames per second, not 25 frames per second. And you will immediately feel that this is television, that this is some TV show, some news or something like that, not the movie. And once again, not only because of the color correction, but also because of the interlaced feature of this video. And in our case, this is part of some TV show, and it's to be inserted into the whole TV show, so it should look the same as the rest. And if you simply de-interlace this video and give it to the station, they will insert this into this whole show. It will be different, and the viewer will immediately see that something is wrong, something is not right. And of course you don't want that, so you would like to preserve this interlaced feature. And you know how to do it because I have showed it to you. And we couldn't simply use the interpretation of the footage so that it doesn't separate fields, because we had to scale this footage down. And as you can see, when we scale down this, you destroy the fields, right? So we had to use another approach. And we did only two things. We interpreted the footage correctly. This is one thing. And we added this to the render queue and set the proper render settings. That's all. But now we really understand what is going on. So when we interpret the footage to separate fields, to upper field first, it means that the footage is now de-interlaced. Now, it's also good to preserve edges. This interpolates the missing lines better. In the composition window, you will see only the upper field, but it doesn't mean that the lower field is missing. It's there. And we make use of it when we set the render settings properly. So we have both fields, and then we scaled the footage a little bit down, but both fields are first interpolated, then scaled down, and then when the render settings are set properly, the footage is interlaced again. And that's what we did. And if you, for example, want to deliver this kind of shot to television and to internet, you have to render two versions. First, with the render settings set so that the fields are separated, and the second one normally with the default render settings. Okay, so that's it from me. I didn't show you any fancy techniques, I didn't show you anything exciting, but I hope that it was useful for some of you. Bartek Skorupa for AE Tuts Plus. Thank you very much. Take care. Bye-bye.